Three-phase AC generation. The AC available at our homes requires just two lines, a phase and a neutral. This is a single-phase AC supply. Most of our appliances like lamps, fans, etc. are low-power devices which consumes less than a kilowatt. But industries requires electric motors with power ratings of hundreds of kilowatts or even more. To get more power from AC, the device will draw more current from the source. To carry heavy current, the conductors of the transmission line must be very thick. This increases the cost and weight of the conductors. From the viewpoint of the power company like KSEB, this is undesirable. So, there must be a method to transmit large amounts of power with minimum conductor volume. Three-phase AC offers a solution to this problem. With three-phase power, we can transmit 3 times the power with just 1.5 times the conductor that is required for a single-phase AC. A three-phase system consists of 3 conductors to transmit 3 times the power. Consider a basic alternator scheme like this. We have a pair of magnetic poles, a rectangular coil of wire wound around a cylindrical armature. The armature is connected to a shaft which is free to rotate. When we rotate the armature, the coil cuts the magnetic flux and an EMF is generated at the ends of the coil. This can be connected to a load through a set of slip rings. The EMF generated in this case will be a single phase AC. Now we add a second coil perpendicular to the first coil. One end of each coil is connected to a common slip ring. The other two ends are connected to 2 separate slip rings. When we rotate the armature, EMF will be generated in both the coils. This will also be an AC with the same frequency as the first case, but there will be a phase difference between the two voltages. When the first coil is at the bottom of the north pole, it will cut the maximum amount of flux and the EMF induced in it will be maximum. At the same time, the second coil will be midway between the poles. The flux cut by the coil will be 0 and hence the EMF induced in the coil will also be 0. This means that there is a phase difference of 90 degrees between the generated EMFs when the coils are separated in space by 90 degrees. In three-phase AC, we generate 3 sine waves that are equally spaced from one another. One complete cycle of an AC is 360 degrees. So, the 3 sine waves are 120 degrees out of phase with each other, like this. Here, phase 2 lags phase 1 by 120 degrees and phase 3 lags phase 2 by 120 degrees. To generate three-phase AC, the generators have 3 sets of coils. These coils will be spaced 120 degrees apart to one another. When these coils are rotated in a magnetic field, 3 sets of EMFs are generated across the coils. They are suitably connected to get a three-phase supply at the output terminals of the alternator.